So, register file structure and addressing mode. How we are going to use the addressing modes in the register file for accessing the data. Okay, that is going to be seen today. So, register file structure is this is the diagram of register file structure. Here, your address of the register file is from 00 to FF. Okay, so full and full hexadecimal value only. That means here it can be able to hold 8 bit. Okay, that is 00 to FF. See here, here register file going to be divided into two banks. Okay, bank 0, bank 1. So in bank 0, it will be ranging from 00 to 7F. So 7F க்கு அடுத்த நம்பர் என்ன 80. Okay, so 80 ல இருந்து FF வரைக்கும் bank 1. So two banks will be activated in register file. So each bank will be having 128 bytes of capacity to hold the address. So the term register file is PIC terminology used to denote the location that an instruction can access via an address. So register file is nothing but a memory device. Okay, or register storage device which used in the PIC microcontroller for pointing out the address of your instruction. Okay, so instruction order address will be pointed out by the register file, or it will store the address of your instruction in the register file. So the register file consists of two components. One is general purpose register file and another one is special purpose register file. So general purpose register file is nothing but a RAM. Simply we can call it as a RAM. Okay, random access memory. You can able to write or read in the RAM device. So from 1F to 7F, it will be activated as the RAM device in the bank 0. So in the above 1F, that is 00 to 1F, it will be acting as a special purpose register. That means it will be reserved for some other work. Okay, அதே மாதிரி இந்த bank 1 the RAM device will be activated, that is general purpose register will be from the 9F to FF. So above 9F, that is 80 to 9F, it will be activated as a special purpose register, that is for reserved one. Okay, reserved cases. So here you see the general purpose register file. The general purpose register file is another name for the microcontroller's RAM. Data can be written to each 8-bit location, updated and retrieved any number of times. So you can write data as well as read the data, whatever you want. You can do at any time, any number of times in the RAM device. That is said to be general purpose register. Then special purpose register file contain input and output port as well as the control register. Here you can send the data as well as receive the data in the register with the help of control register. Okay, so control register will indicate whether you are going to write or read. Okay, write means you will be using input port, read means you will be using output port. Okay, so that will be indicated by the control register. So the control register used to establish each bit of a port as either an input or an output. It contains register that provide the data input and data output to the variety of resources on the chip, such as the timer, serial port, and the analog to to digital converter. So you can transfer the data in between the other devices which is present in the microcontroller, that is timer, serial port, ADC, DAC, whatever it means. Okay, you can transfer the data in between these components with a register. Okay, so it has register that contain control bit. So here you will be having control register which will have the control bits for selecting the mode of operation, whether you are giving the data or getting the data. Okay, reading or writing, or giving input or output. Okay, that mode will be indicated in the control bits or control register, as well as enabling or disabling its operation. It has register containing status bit which denote the state of one of these chip resources. That means here it will be holding, the control register will be holding the status bit also, so which will indicate the ஏன்டா இப்படி பண்ற, கிளாஸ் எடுத்துட்டு இருக்கல, போய் அங்க போய் பாரு போ, இப்படி வச்சிட்டு பாரு, செவுத்துல வச்சிட்டு பாரு போ. என்ன வேணும்? ஆ ஸ்டக் ஆயிடுச்சா போன்னு? என்ன பார்த்தேன். Sorry. So it has register that contain control bits for selecting the mode of operation of a chip resource, as well as enabling or disabling its operation. It has register containing status bit which denote the state of one of these chip resources, that is serial data transfer complete. So here the control register will be used as a indicator of status. Okay, which will be indicated in the status bit about the state of your register. Okay, so for example they given serial data transfer complete, the transferring of data serially to the other device is completed or not, that will be indicated by a status bit register. Okay, the register file structure is given here. Okay, this is your structure of register file, with addresses that span the 8-bit range from H00. H will be indicating the hexadecimal value, so ranging from 00 to FF. So because the direct addressing mode employed by many instruction uses only 7 bit of the instruction to identify a register file address. In a direct addressing and